Hello and welcome to this SSE Community Discussion Hour. My name is Annalisa Ventola. I'm the editor of Edge Science, and I will be your host for this event. I have with me Patrick Huyghe, who is a writer, editor, publisher, and television producer. He spent two decades writing about science for magazines from Omni to Discover to the New York Times. He was a staff writer at Newsweek, produced television documentaries for WGBH and WNET, was the editor of SSE's Edge Science for more than 12 years, and is the author or co-author of 9 books. He is currently the editor and a publisher of Anomalous Books. Patrick, it's a pleasure to have you with us today. I invite you to begin your presentation, and I will clear the stage.
Thank you, Annalisa. Welcome, everyone. Those of you who already know about the discovery of small comets probably have doubts about it, as it's quite a controversial subject. Those of you who are not familiar with it are quite frankly in for a big surprise. Today, I will tell you how the small comets were discovered, and I will show you as much of the evidence as I can squeeze into my presentation. I will not discuss the details of the controversy. That would take all day. You'll have to read the book for that part of the story. But I will tell you how I became involved in the story. I'd like to begin by giving you a little bit of background about the man behind the discovery, Louis A. Frank. Frank was a space physicist at the University of Iowa. As an undergraduate there, he assisted James Van Allen in the calibration of the first U.S. lunar probes, Pioneer 3 and 4. At the time of the discovery, he was regarded as one of the most respected space physicists in the world. He was responsible for more scientific instruments aboard spacecraft than any other scientist, having been an investigator, experimenter, co-investigator, or principal investigator for instruments aboard 42 spacecraft. His scientific accomplishments were many. He discovered the theta aurora, made the first measurements of the plasma ring around Jupiter and Saturn. He was the first to measure solar wind plasma funneling directly into the Earth's polar atmosphere, and he discovered the belt of ions around the Earth known as the ring current. Now, in August of 1981, a spacecraft called Dynamics Explorer 1 was launched. It's basically an Earth observing platform. There were many scientists who had instruments aboard the spacecraft, and Frank was responsible for 3 of the instruments, one of which was the ultraviolet camera, which was built and operated by his colleague, John Craven. The ultraviolet camera, which was designed to study the Earth's aurora, which is Frank's interest, shows the Earth's dayglow, which is produced by the interaction of sunlight with the atomic oxygen present in the Earth's upper atmosphere. The images that came back from the UV camera were normal, except they were speckled with some very puzzling dark spots. Now, normally, scientists will just ignore things that don't directly pertain to what their interests are. But Frank didn't like to know about everything that was going on in his images, and these dark spots really annoyed him. So what is a scientist supposed to do when you can't understand something? Well, you assign the job to a graduate student, in this case, John Sigwarth. So he looked into whether these dark spots were due to faulty instrumentation, radio transmission noise, failing sensors, paint flecks on the camera. What were those black spots? So Frank concluded, after a few years of putting John Sigwarth to work on this, that there was something between the satellite itself and the region in the upper atmosphere being observed. Something was absorbing the ultraviolet light in that region and creating a kind of dark atmospheric hole in the uniform glow of the Earth. Frank and Sigwarth found more than 30,000 such spots in images during some 2,000 hours of observing time. Whatever the black spots represented, they showed the prograde motion that is characteristic of meteorite material. But these dark spots were enormous, measuring about 30 miles in diameter at an altitude of 200 to 600 miles above the Earth. These could not be rocks. So what could it be? Well, water just happens to absorb at the wavelengths they were observing with their camera. But no amount of evaporation from the surface of the Earth could produce such large clouds of water vapor at that altitude. The water had to come from out there. Frank's conclusion: these dark spots are what remain when small comets, house-sized chunks of water snow, are vaporized above the Earth's atmosphere every minute. So we're talking about millions of small comets incoming each year. That was the problem. If Frank had said there was 1 comet, 10 comet, maybe 100 comets coming in a year, I don't think the hoopla would have been what it is. But obviously the criticism came down very hard on Frank. Now what's interesting is that the black spots would appear and disappear in a sequence of frames. The black spots seem to be objects in motion. Frank concluded that the gradual appearance and disappearance of a single atmospheric hole is caused by a small comet in a sequence of images taken 42 seconds apart, as you can see here. These images reflect the transient nature of the water vapor clouds, or the remains of small comets, as they plunge into the Earth's atmosphere. Frank's discovery was announced in Geophysical Research Letters in April of 1986. This is the cover of the journal where it appeared. And you see at the top the ring, which is the ultraviolet image of the northern auroral oval. Now, Alex Dexler was the editor of the journal at that time, and he allowed Frank to have 2 papers in this issue. One was the data paper, the other was the interpretation. No one had any problems with the data paper. The data paper was what it was, but the interpretation caused the firestorm. Dexler ended up publishing 11 critical comments. They covered a very broad range of subjects, from geology to planetary atmosphere, and from lunar science to astronomy. Frank replied to each one. It took him over 1.5 years to do so. Now, if one satellite were seeing these dark spots, maybe there were other satellites as well. Well, there just happened to be a Swedish satellite in the air at that time, and he was allowed to examine some of their images, and sure enough, he spotted the dark spots in those images as well. One of the people who was interested in Frank's theory was Thomas Donahue, who was a respected atmospheric scientist at the University of Michigan. He looked at Frank's space papers and said, if Frank is right, these comets would have brought enough water over the edge of the Earth to produce oceans. Now, this really surprised Frank because he had always assumed that the oceans had always been here, and so did everybody else, based on a very famous paper by William Ruby, that was published in 1951. Everyone cites Ruby's paper as saying that the water must have been here at the beginning. But if you look at Ruby's paper, he did not say that. He actually said that the water must have arrived on the surface of the Earth over time. I don't think he meant to the present day, however. Now, one geologist who was interested in all this, a geologist at the University of Oklahoma, Dave Deming, later published a paper in the journal Paleo supporting the idea that the oceans must have formed through a gradual accretion of volatiles over time to the present day. This is where I came into the paper. The New York Times at that time published an article about Frank's theory and the possibility that they were responsible for the formation of the oceans on the Earth. I saw this, and being a science journalist at the time, I pitched the idea to an editor I knew at Oceans Magazine. The editor gave me the go-ahead, and I contacted Lou Frank, interviewed him at length, and my article ended up being published in Oceans Magazine. So that was my first encounter with this story. Now, one of the things that's puzzled atmospheric scientists for a long time are noctilucent clouds. There's not enough water thought to evaporate from the Earth's surface and reach altitudes of 55 miles to form these clouds. But if the small comets are bringing water in and depositing a little of it in the upper atmosphere as it gets injected into the atmosphere, then the mystery of these clouds has a very simple solution. Something else that's puzzled scientists for a long time are transient lunar phenomena, these momentary glows that appears on the moon's surface. And here is an image from a series of frames taken by some Greek astronomers in 1985. These exposures are taken 8 seconds apart, and the impact of a small comet on the moon would produce such a momentary glow. Now, one of the people who was very interested in Frank's theory, actually was very skeptical of it, was someone named Clayne Yates at the Jet Propulsion Laboratory. At the time, he was working on the Galileo project, but the Galileo project was delayed because of the Challenger disaster. So he decided to see if he could search for the small comets using a telescope. Now, there are not many telescopes that are usable for near-Earth objects, but one of them was the Space Watch telescope in Kitt Peak in Arizona. So he got together with Frank, and they discussed exactly how the search should be run to find small comets. Now, Yates managed to get the first optical images of the small comets. The large streaks in the image are star trails, but a faint small comet trail appears as well. It's the slanted line, the faint slanted line in the outline box. These small, dark, fast-moving objects have so far only appeared in images taken at the very limits of detection. Now, these small comets appeared in a number of Clayne Yates images from the search. Here in the top image, you'll see that Frank has tried to identify everything in the image, from star trails, cosmic rays, counting statistics, CCD effects. But once again, in the box, you'll see the characteristic slanted line of a small comet. These exposures were taken by astronomer Tom Garrels in April of 1988. Now, the same comet seen in the top image is seen in the box in the following image, which began 36 seconds later. Taking consecutive frames of the same object is the standard of proof in astronomy, normally. But after seeing this, the critics wanted 3 consecutive images of the same object to accept that the streaks were not noise. Still more evidence. Michael Amendola, who was a professor of astronomy at Boston University, was curious about all this. And in 1988, he sent up a sounding rocket from Wallops Island in Virginia. The payload of the rocket released 584 pounds of water vapor, ice, carbon dioxide, and debris 185 miles up into the atmosphere. Almost 4,000 miles above, the Dynamics Explorer satellite had been reprogrammed to take a series of 1-minute images of the narrow region surrounding the release of the rocket's payload. And indeed, Dynamic Explorer managed to spot the event, showing that Frank's proposal was, at the very least, quite plausible. Somebody else who was interested in this was a meteorologist at Penn State University, John Olivero. He wondered, is there really a large amount of water in the upper atmosphere? After repeatedly observing short-term perturbations in microwave spectra, he concluded that these temporary increases in water vapor concentrations in the other atmosphere must have come from extraterrestrial events. So after Lou Frank saw my paper in Oceans magazine, he contacted me and he asked me if I would be interested in writing a book with him about his discovery. I thought I was very surprised by this because my article starts out rather skeptically about his finding, but apparently he liked it enough that he offered this to me to write a book, and the book appeared in 1990, and it gathered some, it didn't make a big splash, it made a little splash, but the reviews were good. That's not the end of the story, however. While Frank was getting data down from the Dynamics Explorer satellite, he was also working on other instruments for a forthcoming spacecraft called Polar. And he decided to tweak a few things to be able to learn more about what these black spots were and the small comets. While the Dynamics Explorer showed the atmospheric holes in single pixels, this led critics to dismiss the phenomena as instrumental artifact. But on the Polar spacecraft, you see clusters of pixels. This was taken by the Visible Image System on NASA's Polar spacecraft in 1996. These black spots in the image are caused by water vapor clouds from small comets disintegrating anywhere from 600 to 1,200 miles above the Earth. The water vapor clouds momentarily and locally absorb the Earth's day glow as viewed from the Polar spacecraft. When the news broke about this finding, people called it a vindication of Frank's provocative theory. And in 1997, this made the front pages of the New York Times, the Washington Post, and other newspapers. Now, Frank's images above Polar managed to produce a lot of other images that supported Frank's conclusion. This image of the sunlit Earth, seen in the far ultraviolet, was taken by by camera aboard Polar. The image has a multitude appearance because of intensities in this spectral window are factors of 1 million dimmer than those for visible wavelengths. This is a record of the final moments of the disintegration of a small comet. Now, one thing that was very interesting about Polar is that when Polar was first sent up, there was a misalignment of the center of gravity and spin axis of the spacecraft. This unintended swaying motion in the spacecraft's platform, which they were later able to compensate for, caused things that's seen in the line of sight of Polar to appear double or cat's eyes. Here are two frames. The one on the left is a star showing up doubled because of the problem. And here is an atmospheric hole showing up doubled, again, because of this misalignment in the imager. So once again, this lends credence to the fact that this is a genuine geophysical phenomena. More images, the raw images on the right. For small comets bursting at high altitudes, trails of bright glows from atomic oxygen were observed by the Polar spacecraft high-resolution Earth camera for ultraviolet wavelengths. These trails are distinguished from artifacts due to penetration of energetic charged particles into the camera's sensors by a sequence of electronic shutter closings during the exposure period of the image. Thus, a real oxygen trail is identified by alternate brightenings and dimmings along the trails. You can see how it's cut up along the trail. An energetic particle will not have this same distinctive fingerprint. Here is a long oxygen trail from the disruption of a small comet passing by the Earth at a large distance. Now, unlike the large comets, which are detected by their comas, small comets can only be detected by reflected sunlight. And because they are so faint, they need to pass much closer to the Earth than the large comets in order to be seen. But if they do exist, some astronomers have realized, there would certainly be many of them, as very likely they would be indistinguishable from the meteors we see entering the atmosphere. Now here are subframes from two cameras aboard this polar spacecraft. One is the visible and one is the UVI, that show the day-glow intensities at the same location in the Earth's upper atmosphere, both before, during, and after the occurrence of an atmospheric hole produced by the deposition of water vapor from a small comet. Whenever a large atmospheric hole was detected in one camera's frame, it was detected in the other camera's frame. This series of observations provide a conclusive identification of atmospheric holes as a genuine geophysical phenomena, according to Frank. Here is a diagram basically of what happens. You have an incoming small comet, about 40 feet in diameter, containing about 100 tons of water vapor, moving about 10 miles per second. The comet breaks up about 800 miles above the Earth. The comet vaporizes about 330 miles above the Earth, producing a cloud of water vapor about 30 miles in diameter. And the dispersal, as the water vapor gets injected into the atmosphere, it's dispersed by the upper atmospheric winds, and finally the water vapor condenses into the Earth's oceans. Now, the small comets are thought to be responsible for a tiny fraction of the annual rainfall, depositing only about 1/10,000th of an inch of water on the Earth's surface per year. Here's another image from Polar's low-resolution visible camera recording the emissions from the OH molecules when the small comets plunged toward the upper atmosphere and disrupted and vaporized by sunlight. This is a multiple exposure, 3 consecutive snapshots in one image of the event taken 6 seconds apart. A view of the Earth has been superimposed on the image as there are no detectable emissions from the Earth's nighttime atmosphere at the wavelengths where these oxygen-hydrogen molecules glow. And you probably can't see the charts on the left-hand side, but I'll describe what they are. The top are the results from Polar from November 1997 through late January of 1998. This is the frequency of atmospheric holes. The middle chart is from Dynamics Explorer, which was taken 16 years later, once again showing the same seasonal variation, a November high and a January low. The bottom chart, which is really interesting, this was taken 42 years earlier, and it shows the non-shower forward scatter meteor rates observed in Ottawa, Canada. It's no mystery why the atmospheric hole rate should correlate so well with the meteor rate measured by forward scatter radar. After all, small comets are just a part of the meteoritic dust and debris that orbits the sun and falls into the Earth's atmosphere on a daily basis. Forward scatter radar is ideally suited to reflect the infall of small comets. The shaded areas are the shower times. Okay, where does the story stand today? Well, in April of 2003, Louis Frank suffered a stroke that effectively ended his career. He died in May of 2014. At that time, I called Bob Hoffman, who was the NASA project scientist on Polar, and I asked him, have the small comets effectively been proven wrong? And he said, no one has come up with an interpretation that would take into account all of Frank's data. Frank's partner in small comet crime is John Sigwarth. He had gone on to become a senior scientist at NASA Goddard. He died in December of 2010 of an aortic aneurysm at his home at the age of 49. Then in January of 2021, John Craven, a research scientist who built the imager for Dynamic Explorer and was the third author of the original Small Comet papers, he passed away in Alaska of ALS. Without a living advocate, the general consensus was that the comets, small comets, were dead, that they had been proven to be non-existent. So then in March of 2021, I received an email from Bill Abbott. He had read The Big Splash and urged me to get the book reprinted. He said the small comet discovery should not be forgotten. Now, he was unaware that in the early 2000s, Frank and I had written an additional 40,000-word follow-up about the polar results and the continuing controversy after The Big Splash had been published. This material had never seen the light of day. We had tried to convince the original publisher to issue a new edition of The Big Splash, but they declined. So basically, that manuscript, the 40,000-word additional manuscript, sat in a box in my garage along with the supporting materials. So I thought that Bill Abbott was right. His discovery should not be forgotten, so I obtained a reversion of rights to The Big Splash from the original publisher. I contacted Lou Frank's daughters, who are the beneficiaries of his estate, and they allowed me to publish a book which is now called Cosmic Rain, the title that Frank originally wanted for the book. I have become the de facto historian of this controversy. I will end the presentation with the same idea that I ended my original Oceans article. The history of science is full of wild ideas, some of which turned out to be right. The continents are moving and at one time formed a single landmass. Life arose from a few elemental molecules in the Earth's primordial broth. Humans are descendants from the first primitive life forms. In the light of those ideas, Frank's small comet's discovery appears rather tame. So that's my presentation. You can obtain the book. It's a large format, full color book from Amazon. You can see more information about the book on my website at anomalousbooks.com. You can see all of Frank's papers, over 15 papers, at the Small Comets website at the University of Iowa, smallcomets.physics.uiowa.edu. And if you have any questions about the book after this presentation, you can email me at cosmicrainbook@icloud.com. Thank you, everybody.
Okay. Wow, that was an incredible presentation, Patrick. I mean, what a surprise.
Thank you.
I'm first, I want to invite those of us in the audience here at AirMeet to please put your questions, if you have them, in the Q&A section. Also, there is an option to raise your hand and to come on stage and ask your question directly of Patrick. If you use that feature, do keep in mind that this session is being recorded and live streamed. And so as we wait for the audience to formulate their questions, I'm still trying to formulate mine, because this is a really kind of stunning thesis. So what is the current status of this theory? Is it still completely ignored, or?
It's basically, once Frank and John Figgeworth passed away, no one has actually followed up on this. And it's basically been ignored. And when I tried to get this book reviewed, when I published it at the end of last year, the book review editor for a magazine said, "Oh, the small comets have been dismissed. It's not true." Well, they haven't. That's the problem.
Right. I mean, you said in your talk that Frank spent like a full year responding to criticisms of his research. Were his explanations successful?
Well, it was heavy, put it this way, it covered so many fields of science, and it covered it in such detail that he had to familiarize himself with all sorts of things. And he actually thought he answered the critics well enough.
Yeah. So, I mean, the implications of this is it's huge, really.
It is huge.
So what this suggests is that perhaps water did not form itself on Earth, but it has, was deposited from elsewhere.
Right. Well, the original theory is that the Earth was deposited on the Earth at the beginning through asteroids. And basically all the Earth has always been here, more or less, and will always be here. And Frank says, no, it was gradual accumulation and it continues to this day, which of course has implications for climate. One of the things that Frank tried to do is try to convince people who had created some climate models to inject this factor into their climate models to see how it would affect it. And the person who had promised to do so kept promising, and never did, unfortunately.
Yeah. I mean, first of all, if the suggestion that this is enough comets to fill our oceans, that's a huge amount of water. And then also the suggestion is that we're being bombarded by these small comets constantly. And I think you said in your presentation, like we're looking at a sea level change of about 1/10 of an inch per year, right?
1/10,000th of an inch per year, yes.
Okay. But still, like if this excess water keeps accumulating, we're looking at possibly a much more watery planet in the very distant future.
Well, some of it evaporates into space. Some of it goes subducted into the ground. There is water underground.
Okay. Is this
But
comparable?
let me just say, Frank ended his book by saying, it'll be a while before there's a beach in Iowa.
Okay. Yeah, you got to. That's what I was thinking. So we do have a couple of questions here. I'm going to start with a question from the SSE president, Margaret Moga. So she asks, so most of the meteors and fireballs are actually small comets? Question mark.
No. Meteors and fireballs are caused by rocky objects. Small comets are like big, fluffy snowballs with a thin carbon crust. So these incoming small comets are not visible to the naked eye, whereas meteors and fireballs are.
This was in our chat. Can you actually see that? It says, if small comets bring in water, what are the implications for global warming and drying of large parts in the planet, if any implications?
Well, that's a good question. Not one I'm able to answer. I'm not a specialist in this field. I'm sure I wish Frank were still alive to be able to answer these questions.
Indeed. And then we have a question too from our support staff actually here at the SSE. He says, congrats on your presentation. With the advancement of astronomy and the launch of the Webb telescope, can you envision any research follow-up that might emerge in the upcoming years to provide more data or some additional hypotheses or conclusions?
Okay, well, one thing that's important to realize is that most telescopes are not geared to observing near-Earth events. There are actually very few telescopes that can do that. Most of them are focused way out in space. Now, I don't think the Webb telescope is able to do that. There was some discussion while Frank was alive of actually using the Hubble telescope, but it would have required making changes to the calibration and the focusing and everything else of the Hubble telescope, and he did not want to be responsible for messing anything up. So that said, there are now other telescopes tracking near-Earth objects, and it's possible to use these other telescopes to have a dedicated small comet search. However, it requires a very specific search to do so. Basically, you need to use the telescopes in a skeet shooting mode, so that you're actually tracking the small comet as it moves. You can't have just a fixed spot. Something else that Frank wanted to do while he was alive, he wanted to equip the shuttle astronauts with a special camera. He thought that if they used the special camera, they could actually see these small comets coming in. And he was working with someone to provide the astronauts with this special camera, but it never materialized, because once again, I think the Challenger disaster changed the sequence of programs that were available for subsequent flights, and it never made it on a subsequent shuttle flight.
I was also thinking along the lines of the current Galileo project, where they're actually looking at the near-Earth atmosphere for, well, extraterrestrial signatures. But I wonder if, it would be possible for maybe there to be some accidental discovery of these small comets as they pay a little closer attention to the Earth's atmosphere.
Well, I think the Galileo project with the astronomer from at Harvard is more interested in, he was more interested in objects inside the atmosphere,
okay,
rather than outside the atmosphere. We're talking, hundreds of miles to 1,000 miles or so above the Earth.
We have a raised hand from one of our SSE members, so I'm going to invite Mark to stage.
Oh, great.
Hi. Thank you so much for taking my question, and I wanted to thank you for this presentation. So I'm going to admit, first of all, I'm not a scientist, and I'm not a journalist and all those things, but I'm more of I'm an IT person, but I kind of represent the common person on the street. So with that being said, I apologize. My question seems elementary, but
not a problem.
My basic understanding was that the Earth's water was seeded by comets to begin with. So this just, to me, it would seem as though this was just an advancing understanding of that. Almost like instead of saying, like when people said, oh, well, Darwin thought evolution was one big thing. Well, we've now come to refine and nuance that understanding. This is merely a nuancing of the whole idea of there were comets way back when, they seeded it once, and that was it. No. Of course it doesn't work like that. This is just merely a refining of that whole idea, which it would seem silly people would fight against that, considering science is always refining its understandings of things. And so if it's like, well, of course, Mark, you're not getting it because of X. Yeah, common people probably won't get some of that. So that's why I'm asking the question, so I can refine my understanding when I try to explain this back to somebody else. With that, thank you, and I'll take my question.
Yeah, well, I think you're absolutely right. It is a refinement. The only problem is that it brings the refinement to the present day. And people don't like the idea that the Earth is currently being bombarded by small comets. That's disturbing. And they rather have it happen way in the past. We're fine with that. The thing is, we tend to think that the Earth is isolated from the rest of the universe. It's not. It's constantly being bombarded by rocks, by dust, by volatiles, by small comets, constantly coming into the Earth. So it's really not that surprising. And when I showed you those three graphs of the frequency of of these atmospheric holes, as well as the forward scatter meteor rate, they were all about the same. So it shows that this is all the incoming material. It's just all sorts of things coming in all the time.
It looks like I lost my connection for a moment. Can you guys hear me okay?
I can.
Okay, good. That was scary. Hopefully, won't have too much more of that. We have a lot of questions here, and I want to ask the audience to help me out by visiting the Q&A and upvoting your favorite questions. So I have another raised hand, but I think I want to ask one of these questions. A couple of questions from the Q&A first. So stand by, Carl. We will get to your question. We'll start with this question. It says from Herb Mertz, with so many objects incoming, wouldn't the International Space Station need to be watching for them? And even if they were not a threat, wouldn't they see them nearby?
Okay, well, first of all, I think the space station is an altitude where it would not be a threat. These small comets would not be a threat. Now, there's an interesting episode from a book about the Mir spacecraft, the Russian Mir spacecraft. That at one point they heard a couple of thumps and they saw all these like flakes all around their capsule, and they were wondering what just happened. And Frank believes that they could have been, seen the breakup of a small comet, the disintegration of a small comet around their spacecraft that turns into basically vaporized water, ice, and snow.
Roger Nelson asks, is the 1/10,000th of an inch of a measure of the depth of a layer over the whole Earth? If it were so, wouldn't we have all drowned long ago?
Well, no. That's basically how the Michigan atmospheric scientist calculated if you've got 1/1000th or 1/1000th of an inch a year over the age of the Earth. He said, well, basically, that's the amount of water we have in the Earth's oceans today.
Okay. I'm going to pass the mic now to Carl, who is, I believe he is the representative of the associate members of the SSE. And let me hand the mic to him and see if he's still around.
I'm here.
Hello, Carl.
Hi, Patrick. Let me see if I can turn my camera on. I guess it's not important, but oh, there it is. Yeah. Okay, so just a quick question. I've read that there's always been talk about is or has there been water on Mars? Could that also have accounted for that as well?
Okay, what's interesting is that in the 80s, it was thought that the solar system, there was very little water in the solar system. People suspected, well, maybe there's water on Mars. They couldn't quite figure out where it was, but they thought there might be water on Mars somewhere. But since then, in the past, 35 years, one discovery after another has come up. Oh, there's water on the moon. There's water on Mars. There's this, the moons of Saturn, Jupiter are full of water. I mean, it's like the solar system is drenched in water at this point. I mean, if you read the book, some of these discoveries are mentioned in the book, and there have been many discoveries since 2001 where basically the book ends. But if you look for water on various moons, on various planets, there's constant discoveries, and it makes sense. If the Earth is being bombarded by these small comets, so is the rest of the solar system. The question is, how far in does it get? How far in do they get before they're vaporized by the sun? Do they reach Mercury? Actually, water has been discovered on Mercury, volatiles.
So there's nothing unique about Earth and water in the theory.
No.
So it's universal. Seems to be universal.
we like to think we're unique.
Yeah. Okay. Right. Okay. Makes perfect sense.
Yeah, thank you, Carl.
Thank you, Carl, for your question. We have one final question in the Q&A. I think it's a good one to wrap up with today. It says, thank you, Patrick, for your presentation. Why do you think there was such fierce resistance to this hypothesis, especially since, as you say, in comparison to some others, this one was relatively tame? Were certain implications too hard to accept?
Well, it's not so much the implications, it's the very notion of being bombarded by a million, maybe tens of millions of small comets every year. I mean, the astronomers responded to Frank at the beginning by saying, hey, if these things were real, we would know about it first. We would have known about it. As a matter of fact, I presented this small comet talk to the SSE in 1990, I believe, when the SSE was held in Charlottesville, Virginia. And I started presenting basically the Dynamics Explorer results, not the Polar, which had not occurred at that time. And an astronomer in the audience stood up and said, bullshit, as I was presenting. Of course, the SSE being what it is, the audience said, hey, that's not the way we treat our presenters. So basically, it's hard for people to imagine that this is happening and that no one has discovered it before now. That's why there's been such resistance to the idea. And I understand it. Frank understood it fully well also. But he said, listen, I'm not going to ignore the data. The data tells me these things are depositing water vapor into the atmosphere, and that's just the way it is. Whether I believe it or not makes no difference at all.
Well put. Well, this is definitely an enlightening conversation, and
Thank you.
I'm interested in your book now, so I might just take a look at it. And I encourage everybody else here to do the same. Anyhow, I think that's going to be it for this hour. Following this, we have a social lounge, and I encourage people to visit the social lounge to just discuss your insights from this conversation, and just to catch up with your fellow SSE members. So I hope you'll take advantage of that opportunity, and we'll see you next time. Thank you.
Okay. Thank you very much.